Hello, hi, I am G. Kusmant of Benet University. Today I am here to discuss about my machine learning assignment in which we are using classification techniques like CART, Logistic Regression, Random Forest, Decision Tree, Naive Bayes, and Neural Network to classify the pH value based on RGB colors. Here RGB means red, green and blue colors. In this, we are firstly going to load the data and then we are pre-processing our data. And in the step 2, we are going to split the data into training samples and then test samples. And now, using classification techniques like which are mentioned above, we'll be using techniques and then find the accuracy of the each model, accuracy of the model. Analyzing different classification metrics like MSE, RMSE, precision, recall, accuracy, etc. And then at the last, we'll be concluding which is the best classification technique to divide our data. Firstly, we are going to import our pandas. Now I'll be going to execute my code. Now firstly we'll be going to load our data. Firstly, we'll start with this. We are going to import this pandas, and then this is the read function of my file, which is ph database, which consists of 4 rows and 4 columns and 653 rows. The 4 columns are namely blue, green, red, and the label. You can see it here: blue, green, red, and the label. And in total, I have 653 rows and 4 columns. And now I'll be using my label column as a target variable for my data set. Here. See here I used it, and now I'm dropping the label column from the data set. See, after dropping this I'll get this one. Now I'll be pre-processing my data so that it will be easier for the coming steps. See this, after pre-processing my data, you will get the output in this way. See, we'll get in total 653 rows with 3 columns. 653 rows are common, and the 3 columns, the 4th column which is label, which we have dropped off in the above. See, here we are dropping off the label column. Here, over here. Here we are dropping off our label column. Now we will be splitting our data samples into train sample and test sample. Here we are using test size is equal to 0.3. 0.3 means here we are splitting our data into test and train with 0.3 is to 0.7, like 30 is to 70 ratio. Means if we took 100 samples, there will be 30 going for testing sample and 70 going for training samples. We are running it and we'll get this output 457,3. Now we'll be installing Pyrocto Plus. It takes a time because it will need to install. Meanwhile, I'm gonna show you my blog which I've been written in this. In this blog, I've written all the statements including the steps like the loading data, pre-processing our data, splitting the data into training, using classification techniques, analyzing different classification metrics, concluding which is the best model. See, I have said you have got 4 columns and they are blue, green, red and label. And now after the loading and pre-processing is done, which we have done the step 1, you could see we are this and we will remove the label from our data set. This is pre-processing, we get this, and now we are splitting our data, which we got this, and I have clearly mentioned that we are divided into 70 to 30 to the ratio. Now we are going to start our classification techniques, and now we are using the classification technique decision tree, that ID tree. Here we can come to know that we are using ID tree because our criteria is entropy. You can see it here, we are using entropy to split our data. If we run, we're getting an accuracy of 0.709183. And now we need to plot our graph for the given data. Like for this we need to plot so that you'll get a graph. So when we perform the or when we run the function, we got a graph of id3 in such a manner. So this is the graph of id3 which we get. And now we'll be doing cart technique. Now in the cart technique we'll be using a GNA-imput as a main component. So by doing this we'll get 0.714 accuracy. So it means it is the accuracy score of this card is 0.714 and MSC is 0.913, round off to 0.913, and then RMSC is 0.955, which is round off to 0.956. Now we are looking at the graph which we got from the cart. This is the graph which we'll be getting from the graph from the cart. Now we are going to perceptron. This is a technique, this is another classification technique called perceptron. By running it we get an accuracy score of 0.2602, which is nearly 1/3 of which we used cart and the ID3. Now we are going to neural networks. Here we will be our classification technique is neural networks, and we will be running this and then this and then this. So this is our classification report based on y-test and y-pred. Now we are going to do the logistic regression. Here is what we call a classification technique, logistic regression. Here we are going to run this. And we are getting a score of 0.5, which this means the accuracy score of the logistic regression model is 0.5. Now we will be using the random forest model to check the accuracy. Now we are almost getting the same accuracy as the logistic regression, that is 0.5051. Almost we are almost near the same. And then now we are giving the naive Bayes. We are running it, and then I still got the same thing, 0.5051. Now from we have done all the classification techniques. From this we could see, firstly we'll start with ID3, decision tree. For this we got 0.7091, which is approximate 0.71, which is a good score. And then card we're getting 0.714, and then we're coming to perceptron, which is 0.260, and then we're coming to random forest, which is 0.5, and the logistic regression, which also sums up to 0.5, and the naive Bayes, which is also 0.5. From looking all these techniques, we could get that we'll get the best score in cart and ID3. We are getting cart approximately 0.714, which is the highest, and then we'll get it in decision tree ID3, which is 0.709. So from this analysis I could say that cart and ID3 are best classification techniques for this data set. Thank you.